Is the Energy Institute of NTU. I'm managing two programs, and these two programs will be related directly to the workshop. I manage the first program is related on multi-energy, and the second one is about the power grid. Why we are presenting these two programs is because you'll see that tomorrow the power and the power grid and the districts and large sites are somehow connected and interlinked. The first program is related to district or large site hosting different energy types and sources. That means renewable and non-renewables, power, and also thermal energy. With the following question: how can I reduce my CO2 footprint? How can I cut my cost? While the second program is about the integration of renewable in the grid. You will see that integrating renewable in the grid is not an easy story. There is a limit somehow, and then it creates a lot of instability. So the answer, the question will be, what is the impact of renewable into the grid? How the grid will behave? And then also we have to look at it on the business perspective. Is there new businesses coming in, with this big change of paradigm in the grid? So the presentation will cover, and I hope, will answer most of these questions. What is nice is that we'll be seeing the concept, but not only the concept, but also, the implementation. That means we'll have the voice of the project managers who are today implementing all these projects. I truly believe that it will be a very fruitful session, and I immediately introduce, John. John is the co-founder and CEO of Ever. Ever is a company based, in LA, in USA. They have a very interesting value proposition. It's about, scalability, dispatchability of green power. His pitch is can be shocking because he's proposing an alternative to Singapore, to give to Singapore a full autonomy in terms of energy. John, I believe, you are more knowledgeable than me on the topic, so please, go on.
Interaction and one clarification. The company is actually based in Canada. I'm based in LA, and our clients are our potential clients are around the world. So I'd like to thank the organizers for squeezing me in on such short notice, but I don't want to thank them too long because I do only have 5 minutes, and my goal, changing the world, may require most of those minutes. So how do I want to change the world? How does Ever want to change the world? We want to change the world, or at least Singapore, by introducing an up to now unknown energy option for Singapore, a new form of geothermal energy called Everloop. Previous feasibility studies in Singapore had pegged the geothermal potential of Singapore at only between 60 and 100 megawatts. Everloop holds the potential of increasing this not just 10-fold, but 100-fold. This could facilitate Singapore's transition to 100% clean energy and simultaneously achieve the seemingly impossible dream of Singaporean energy independence. Next slide, please. So how do we get there? As everyone knows, who is attending this conference, I'm sure, Singapore is very reliant on fossil fuels, especially in the form of LNG for 95% of its energy, or thereabouts. 100% of that LNG is imported. Hence, despite Singapore's very best efforts, it is neither fully green nor energy independent. As for domestic energy sources go, for wind, there is simply not enough land in Singapore to make it work, and wind resources are poor at the equator in any event. For solar, it's higher density, but there's still simply not enough space, even if Singapore covers every field, reservoir, and rooftop with PV panels. It's just not enough to make a significant dent in the energy demand. Fortunately, Ever believes it can unlock 10 gigawatts or more of Singaporean geothermal potential with a surface footprint that is 100 times smaller than solar and 1,000 times smaller than wind. Next slide, please. So how does Ever do it? Next slide. So how does Ever do it? I've got no time to explain, but in a nutshell, instead of an oil and gas or traditional geothermal model, where we explore for rare, super hot, super permeable reservoirs, and then try to produce a fluid out of the rock itself, as seen on the left, Ever simply constructs a series of massive, hermetically sealed underground radiators and harvests the heat purely through conduction, as seen on the right. How we do this in a reliable, cost-effective, and repeatable manufacturing process is our secret sauce. and the subject of a much, much longer presentation than the 5 minutes I have today. Next slide, please, page 4. Thank you. The end result of all this development is the creation of what we feel is a previously unknown energy category that is simultaneously truly scalable, green, and baseload. No other energy source does this. And on top of this, unlike any other green solution ever is intermittent, it can act as baseload, even better than that. And unlike traditional geothermal, it's even dispatchable and can load follow, which can certainly help with grid stability, one of the things you were just mentioning, Sharif. In fact, with no emissions, no water treatment, no seismicity risk, and a small surface footprint, it's the most benign form of energy imaginable. Being benign and scalable also makes it distributable, another virtuous attribute. Similarly, being distributable, black start capable, and mostly buried underground, it's also an extremely resilient form of energy against natural disaster, man-made or natural disasters. Finally, unlike wind and solar, it can effectively deliver heat and or electricity, not just one of the others. It truly is the holy grail of energy sources. Next page, please. So, the hour. What could energy independence for Singapore look like? On the ground, or from the air here, it could look pretty much like the status quo. It would involve starting with one 80 megawatt site and growing ever one site at a time up to 10 gigawatts. The sites themselves would be anywhere between 0.5 hectares and 3 net hectares, depending on whether one had aerial cooling or water cooling, and whether or not the surface facilities were buried, partially buried, or made part of another dual-use site. The final bonus, the expenditures to create this energy transition for a decade long or more would be mostly spent in Singapore itself and not on importing fuels or other technology. It could create a cutting-edge green export industry. It would nicely green or clean the product and service value chain of every Singapore-based company. It would represent a multi-generational asset with almost zero op costs that continue operations for 100 years or more. Surely this is the type of initiative Singapore would love to lead the world on. That's our Singapore vision of energy forever. Thank you. Next slide. That's it.
That's it. Thank you.
Did I make it in 5 minutes? I hope I made it.
It's perfect, and you make it.
Okay. Thank you.
Okay, I'm jumping to my proper presentation. It's a presentation about a project that we have conducted with two partners. One, okay, is Jurong Port. It's the implementation partner, and the other partner, okay, is Singapore, okay, Power, and specifically Singapore Power Digital. So let's go to the first slide, please. Next. So first of all, I want to say that there is a change of paradigm. We are seeing more and more renewables. This is not a scoop. But beside this, we are seeing more and more buildings who are hosting different type of energies. In Singapore, obviously, we always have to host on one side the power, on the other side the thermal. But in power, we are seeing building with not only the grid, but also the PVs, batteries. When you have PV, you have batteries, some diesel generators, but also gensets. On the thermal power, we see chillers, absorption chillers, CHPs, thermal storage. When you have, and what we notice that all these energies are here, are there, but they are completely decoupled. Keep this in mind that these energies are decoupled. What we also see on the, so we'll come back on the value proposition. What we also see is that we are also seeing new market mechanism. That means tomorrow, okay, the grid and all this energy world, okay, will have different regulations, and we'll be seeing also new business models, new tradings, and so on. And obviously, digitalization is very present because it makes, okay, our future, okay, possible. And it's really the common thread of all the technologies. Next slide. This is a very old, next slide. This is a very old slide, 10 years old, but I always enjoy to show it. It shows you when energies are decoupled. Typically here, this is it's an average. There is nothing worse than an average, but at least it's very significant. We see that when energies are decoupled, we have very big losses. You cannot imagine that you can go up to 60% losses. In Singapore, you'll tell me, yeah, what's about Singapore? In Singapore, what we have a measurement in the chemistry, in the chemical industry, there are between 30 to 35% losses of energy because it's decoupled. That means they have a lot of steam, they may have cogeneration, they have the grid, they have some microgrids, they have the gas. And when you put all this together, you see that we lose 30% of our energy. So next slide. So what can be the value proposition? So we have to find a system who enable us to completely manage as a whole all these energies. That means we have to find a way to couple them. So we have developed a system that I'm introducing called Smart Multi-Energy System. This system, will have the mission to be able to dispatch energy, or the mix of energy, to reach, an acceptable cost and to reduce the CO2 footprint. That means the system will give orders to the different sources of energy, alternatively, in parallel or something together, or sometime together, to start, to supply the power to reach, the minimum imprint of CO2 and obviously of cost. So the project we have decided with Jurong Port, with JP, we have 3 targets. Energy saving 20%, cost saving 30%, and CO2 footprint less 20% CO2. Next slide. Next slide, yeah. So just a picture of a harbor. It's a multi-purpose harbor. 40,000 vessels a year, very big land. But what you'll see when we go into the harbor is how much this harbor is rich in terms of lab for us. The harbor is also 16 megawatt, but notice that 10 megawatt are coming from solar. So it's a very peculiar harbor. We'll go more in detail after in the presentation. Next slide. So what is the solution? The solution obviously comes into 3 parts. I will call it's a software suite. Today, the system is not, we are not speaking of prototype. The system is running in Jurong Port. So the system has 3 pieces. The first piece is the design. So we start to plan. We want to reach some targets in terms of CO2, in terms of CapEx. We have to reduce the CapEx in terms of operation. We have to have the lowest OpEx. And we have to find the best acceptable efficiency, taking into account the CapEx and OpEx we want to reach and the CO2 footprint that we want to get. So first, we have a first tool. This tool, is capable to help us to design, our site and to make the choices in terms of what different, pieces of equipment will contribute to the targets. So the first one, it's a design tool. So what is the output? The output is a bill of material with list of equipments reaching the capex, the opex, and the CO2 footprint that you want to get. Once you did this, you have the design very well, but then you have to operate. No system. So it's not only about, so it's an AI system, obviously. Artificial intelligence plays a very big role inside, but it's not only about data analytics, because data analytics without control is just cannot by itself reach targets. So it's a tool. We'll go in detail of this tool, capable to dispatch the energy and to choose and dispatch the right energy at the right moment to make, to reach our targets. And the third tool is a maintenance tool. Why? Because a sensor drifts, because, a bad maintenance means, immediately a loss of energy. So the third tool is about the maintenance. So this is our suite. Next slide. Next slide. Yes, this is to give you an idea of the harbor and the complexity. So we are controlling 2 buildings. We have co-developed with Singapore Power a gateway called SPUG, Singapore Power Universal Gateway, to be able to take the data, pull the data from the field. We have a metering infrastructure. We have a lighting infrastructure. We have a warehouse with solar panels. On the other side, we have many rooftops with up to 9.6 megawatt peak solar power. We have obviously a storage unit with batteries. We have it's a AC/DC grid, so we have a protection with AC circuit breaker. All this has been developed by ERIAN. We have obviously a PV optimizer. And we have, okay, microgrid controller. And then we are also experiencing trading of energy. So we have the grid, but also we have a, I said, okay, solar PVs. In here, SIEW, it's our partner for, okay, the solar energy. And then we have also a gas pipeline. We have a cogeneration. With the cogeneration, we have also an absorption chiller and, okay, thermal storage. And here you see really a real example of multi-energy, multi-sources, and so on the heart of the system, we have a capacity to be able to forecast and optimize, okay, what will be the load and the supplies. We are capable to diagnose, okay, the system. Also, we are able to meter, and with this system, we are capable to give a dispatch every okay 30 minutes, okay, to the different and offer a 24 hours every 30 minutes. We have a 24-hour forecast, okay, of use of energy. I go to the next slide, which is very important. Next slide. Next slide. Yeah, here we see the system. So the system is about economic dispatch. I repeat, economic dispatch, it's a cocktail of different sources of energy, enable you to reach the target. And then we have the electric and thermal management, we have the metering, we have the tariff management, and we are also capable to identify faults, detect faults, and do diagnostic in a very short while. So this is very quickly about the system. What I want to show next is just some pictures. I have time. Next slide. So this is the campus. I cannot show the hardware, so I show the campus. So this is the campus. So you see different buildings. You see that you are measuring thermal and electrical power. Next slide. Next slide. Next slide. Yeah. Okay, it's okay here. So we can see one building and okay with okay the sum of power consumption and whatever on the building. Next slide. Here we see the forecast. We see that every 30 minutes we are capable. So you should have a line, but we don't see it, where you have the past and the future. So we are capable to identify what is the mix between gas engine, battery, solar, what is the mix of energy that we'll be using in the next 24 hours. And we do this computation every 30 minutes. And you do it, if you look at it, not only on the left side, which is on the power, but also on the right side, which is on the thermal. And even we combine them. I believe with this, the next slide is about the accuracy. So here you can see the accuracy. Next slide. Okay, you see that we are very good in our forecast. Obviously, the solar forecast is definitely not at the same accuracy that the load and supply. But this gives you, in a nutshell, okay, a big, how to say, a quite clear view of our project. I believe my time is up, and it's time to ask, okay, Mr. Parik to make his presentation. Very quickly, Mr. Parik, okay, is a senior manager in Jurong Port. He's our day-to-day partner, okay, in this project, okay, in Doha Harbor. He's at the heart of the design team, and also he's at the heart of what will become, okay, but he'll explain it better than me, what will become Jurong Port in the future. It will become a living lab for all Singapore to conduct, okay, thermal and power, okay, experiences. And he'll be covering the topic of the next generation multipurpose harbor, because you will see we are really, okay, into the future once, okay, we are into JP Jurong Port. Go on, okay, Parik.
Hi, good morning all. I would like to thank NTU as well as EMA for inviting us here and sharing our journey about innovation and sustainability. Next slide, please. The presentation today is kind of designed to give you a context of the port first, so that we will help you understand the energy landscape in Jurong Port, and then we'll talk about how we have approached innovation and sustainability in terms of the application at both at micro and the macro level. Then we'll talk about SMES as a key vector for making Jurong Port a next generation multipurpose port. Now this is to actually give you overall background. I think generally, like I think Sheriff has really articulated SMES very well, so I'm not going to delve too much into the detail of that. But generally, this should help you understand the overall project itself. Okay, next slide, please. Yeah, let's look at the multi-purpose port context here, and hopefully I can paint a good picture of a multi-purpose port. Yeah, next slide, please. Now, when you see this image, I believe this is what comes into your mind when we, when people think of a port. It's a lot of containers, thousands and millions of them being handled using a standard key crane. Next click, please. Sorry, I think go back. There's animation here. Sorry, you can go back. Next click. Sorry, it should go into. I think never mind. I think there's a glitch over here. If you can go back to that same slide again. The one before. Sorry. I'm not able to perhaps see the other images in this particular slide, but I'm going to kind of verbalize that. Basically, at Jurong Port, what we handle is anything that doesn't go into containers as well as containers. So the pictures in this slide at the background, but I believe you're not able to see here. What we handle is actually cement, steel, your MRT bogies. We also have your flyer, Singapore flyer capsules that came through us. We have a lot of yachts that come through us. We have huge instruments that are required, and for offshore industry, offshore and marine industry. So what I wanted to explain on this slide is to give you a taste of the diversity of cargo that we handle, and from there on, it should then help you understand that to handle diverse cargo, you need diverse kind of equipment. And with that, basically, you can't really standardize like what you see in this particular picture, a crane that is pretty standard and is handling a standard cargo on a regular basis. So the efficiencies in that aspect can't be reaped at Jurong Port. Yeah, you can go to the next slide. So now let's look at the energy landscape in Jurong Port. And perhaps if you can click the next slide, I can explain the way our equipment are designed. Unfortunately, I guess there's no animation being displayed in this presentation. But from the image here on the left side, you can see in the gray box, there are the easy equipments which are running on diesel loads. And then on the right side, you can see the electrical loads, which are totally different in terms of the way they are designed. Now, with design, there's also a difference in the energy consumption patterns, the harmonics and stuff. And of course, and when you look at a big premise, you can see that there is basically infrastructure, there's lighting load, there are office load, there's warehousing, and then all kind of equipment like conveyors and specialized equipment. Yeah, so I can go on to the next slide. I believe I have to bear with no animation, so unfortunately you won't be able to see, I guess, all the slides here. Then when we talk about all these diversity here, I will now articulate how we've approached innovation and sustainability at a macro and a micro level. Now, I think when we talk about innovation and sustainability, typically we try to look at them in two different terms. But when you actually try to put them together, there's a lot of synergy that can be achieved. And I'm going to kind of portray only a few examples over here that can show how when we bring these two together, it can have fantastic results. You can click on the next slide. This particular slide is going to explain to you how we've approached at a macro level using a port-centric ecosystem concept to look deeper into the supply chain sustainability, and how at a very strategic level, when we bring industries together, we can achieve huge sustainability benefits in terms of carbon emissions, as well as efficiency, manpower, and etc. Now, if the host can just help me play this video, and I hope this works again at least.
Jurong Port is Singapore's main gateway for general and bulk cargo. As the premier world-class multi-purpose port in the region, JP serves the needs of the construction industry, offshore marine, petrochemical, and project cargo sectors. Handling more than 90% of Singapore's bulk cement for local consumption and imports, JP has obtained interagency support in 2017 from JTC, BCA, and URA to create a port-centric ecosystem for the construction sector. Equipped with state-of-the-art conveyor belt system and close proximity to on-site batching plants, the proposed ecosystem will provide national strategic benefits by co-locating the main supply chains for cement, steel rebars, aggregates, and concrete together in an integrated facility. Jurong Port's strategic location allows easy access to serve construction sites around Tuas, Jurong, Penga, and the rest of the western region. Besides proximity to the second link, JP is connected to a competitive maritime logistics network with daily services to and from Johor, Batam, and Bintan industrial zones. The deep water berths at Jurong Port can also accommodate mother vessels to call direct at the port. Having the aggregates and batching plants together at JP will reduce national land requirements for the Southwest Cluster from about 29.5 hectares to a compact 11 hectares. More than 600,000 truck trips every year will be taken off the road as a result. Through a one-stop facility, JP will integrate and provide a common user, multi-story facility for shared requirements such as office space, water and sludge waste recycling, weighing, truck washing and maintenance areas, as well as parking spaces. With such a facility, port users can tap on economies of scale to invest in next-generation automation and environmental technologies. By providing an efficient and enclosed storage under shelter for aggregates, this will further reduce land usage by about 5 hectares. JP is the expert in advanced bulk cargo handling methods. Fully enclosed and highly automated conveyors will fetch cargo from the vessels directly to the facility. Dust control systems will minimize any pollution. With cement, aggregates, batching plants, and all other necessary requirements connected to each other, Jurong Port's ready-mix concrete ecosystem will pave the way to transform Singapore's building and construction sector by leveraging advanced technologies. In future, the facility can scale up and reap even greater synergies with prefab and steel clusters. The RMC ecosystem, creating value for Singapore's construction industry.
Yep. Thank you, guys. Hope you can hear me again. In this particular video, you would have noticed that how bringing up different industries to nearer the port has strategically helped reducing so many truck trips. In fact, just for this case of RMC itself, it's about 600,000. But as we develop more ecosystems like the steel that was mentioned and PPBC and prefab hub, we can easily perhaps cross more than 1 million truck trips on road. And that really translates to a lot of carbon emission savings here. Now, this is a very strategic approach on a macro level. Another example, if you can click the next slide, is this study and the venture that we have now gone into together with Chiyoda and other 6 corporations, which is looking into hydrogen as a next generation fuel. And again, Jurong Port being like what even Sheriff had mentioned, a living lab, we are now joining hands with the industry to test bed and also to look at how hydrogen can be landed in Singapore. And with this, basically, we can make the grid itself cleaner. And I believe our friends from Sembcorp here are also a party over there. And I think, and that's exactly what we talk about when we try to introduce ecosystems here that can help achieve greater benefits in terms of the national carbon emission savings. And I think this is a testament because to Singapore's commitment towards green and carbon neutral. because as you know, we have been really developing a lot of solar in Singapore, but we all know that that's not enough. And hydrogen is one of the next generation fuels that can help us get a clean energy. Thank you. Next slide. Next slide, please. Yeah. Now from the, I think one slide back. I guess there's some lag over there. Anyway, so now from the macro level, let's move on to the micro level, and how these two projects have been selected to just give you a taste of how we look at innovation as well as scale and the opportunities that we have in order to actually drive down energy and the emissions. So if you can play a video inside the black box over there. It will give you a view of our solar installation that we have. It is a 9.65 megawatt facility. It's one of the largest in the world for a port, and in Singapore, it's still the single largest single site installation. We have close to about 36,000 panels over there. This was done in 2016. So we were one of the first stalwarts to have this scale implementation in Singapore. Yep. That should give you a picture of the harbor as well. Now the next one is actually a side loader, which where it was a very key innovation for Jurong Port. Wherein we kind of looked at our operation efficiencies as well as reducing the carbon emissions. Now, if you look at the image, you can see two forklifts and a truck over there. So typically handling of steel and rebars, you need a tandem lift with two forklifts, which then loads onto a truck and then the truck moves around. Now, what we did is we actually combined all these functions into a single equipment, which then kind of lifts the cargo by itself and transports it to the yards. Now, with this itself, we have kind of reduced two head counts, which is like more than 50% of it, as well as now gaining productivity. And at the same time, we have reduced more than 25% of carbon emissions because the forklifts have been totally eliminated. Now, these are pretty symbolic. So if you look at the first, the solar portion, you can understand, the electrical loads that we were initially talking about in terms of cranes and the diversity of the equipment. Now that has been kind of taken care of by the solar installation that can help, kind of make them carbon neutral. And in the second part, you can see how we have approached the diesel portion by reducing the equipment itself, to kind of reduce the emissions. Now, this is not where we're going to stop. We are also introducing a biodiesel in near future, and then going forward, we also know that diesel is still diesel, and that's not enough. And that's where actually SMES comes into the picture. So if you can click to the next slide. This is where I'm going to talk about how SMES has played a key role in making Jurong Port next generation port, because first of all, as we operate with this 155 hectares facility, we need to understand the DNA of energy inside the port, and this is where SMES comes really handy. Next slide, please. Next, click. Yeah, I'm glad that it works here. Okay, now on the left side, you can see you can see the kind of variance in the loads of energy that we have, which I've mentioned before. And if you can click the next one. Yeah, and keep on clicking. So you can see now on the right side in the red box, how we are now going to look at various energy sources, which can then combine together, right, as a power bank for us to be activated through the response and demand from the energy market and the data that we receive, which will be now processed in a central platform, which can then help us make business decisions that are driven and supported by the data and analytics by the SMES. So if you can click the next one. And the next one. Yeah, thanks. So this is where exactly where we are coming from. So SMES is going to be the platform to give us the insight, both predictive in terms of our energy loads that are going to happen, and make a right decision based on the energy market prices every half an hour, and make that call to then see whether do we run our gas engine, or do we buy from the grid and use it to charge our batteries? Do we pump our solar into the grid because the grid is paying better? And this is where exactly where what Sharif was mentioning about reducing the carbon is one aspect where we can introduce hydrogen in the system. We can harvest solar in a much more efficient way. That is one part. And the second part was actually making business decisions which are data driven in order to actually then have, I would say, commercial savings. And as you know, premises like Jurong Port, and we are not the largest in Singapore by any means, but definitely when it comes to sizable installation of energy, guzzlers, energy plays a big part of the OPEX cost. And the moment we actually try to optimize this, it really helps us in terms of optimizing our cost as well as the energy and carbon footprint. So I think what I would like to say here is that SMES is a wonderful platform for all those who have a huge installation. And in fact, Jurong Port is just a prototype. We are just a test bedding facility, and there's definitely more to be scaled up, and reap more benefits from SMES over here. Yeah, you can go to the next slide. So in summary, basically, what Jurong Port is going to be benefiting from this SMES project is a better understanding of the energy sources itself, how they perform, and then as a next step, make data-driven business decisions, which are backed by the AI that is being developed in the SMES, and then at the same time gain technical competency in order to manage our port's microgrid. And from there on, we are able to then look into more alternatives of diversifying our energy pool. And with all this, basically, we are aiming to kind of reduce carbon footprint and emissions and help Jurong Port become a next generation sustainable port. Yeah, we can go to the next slide. I'm not sure whether the animation is going to work or not. But anyways, what we want to say here is that when we talk about a next generation multipurpose port, what we mean is that the next generation is then able to breathe a clean air and flourish in a cleaner environment. Thank you.
Thank you very much for your presentation, Mr. Parik. And thank you for witnessing, about, the Living Lab and about, the benefits of SMES. Now I'm going to invite Mr. Ted Chen. I love to tell the story of Mr. Ted Chen because, out of our project, out of SMES, there was like any university, many, publication, this is obvious. But there was around 10 technical disclosure, 2 patents, and also 2 startups. One just being monetized just now, during these days. We'll not talk about it. And the other one was the startup of Mr. Shen, Evercom. It's a very nice story because it started with all the hardship. He'll be telling his story. And today it's a company with a valuation of around $30 million. So please welcome our young entrepreneur, dynamic entrepreneur, and let's listen to his story. Emercom is an energy solution provider, and the core of their business is to master data science. So go on, Ted.
Thank you for having me. Can you go to the next slide? Sure. So Evercom, we are actually a incubator company directly from NTU. We're very much connected to the NTU ecosystem from day one. And our focus has always been how can we use IoT data and AI to help companies or governments better manage the transition towards eventually net zero. So that's really what we have been focusing on. And a lot of our support actually come from the governments. And then with the With all these early track records built with the governments, that's how we managed to start to work with a lot of the regional players. So we're part of the G accelerators. We're part of the PDD group accelerator as well. These are the oil and gas power conglomerates. And then 2020, this year, we started to work directly with the Dubai government as well. So just a bit background of what are the things that we have done. Next slide. So for any startup in the energy space, is actually energy, the industry for energy is quite high barriers of entry. And this is where exactly universities and ecosystem really play a role, right? You can see the journey of how we grow until today. There's many technical hurdles as well as business hurdles to cross. We started with a very simple R&D grant to develop a AI engine to analyze energy efficiency. But as we go along the way, we realized that we need data. So the time that when we realized that data is a gap, that's when we started to partner up with Israeli companies, etc., to build up our IoT capabilities. And one by one, when you start analyzing different assets classes, you know the domain, you need the domain knowledge and etc. as well, right? So it's really a long journey. If the companies want to do a whole end-to-end integration in the sustainability spaces. And this is exactly where, you know, partnership with big companies as well as universities can really help you shorten and also make this whole journey a lot more cost effective. And this is the main theme that I will share about today. Next. Next slide, please. So if you look at the current challenges, everyone knows about the United Nations Sustainability Development Goals. I think all the countries are adopting these goals quite aggressively, marketed quite aggressively. But if you look at the factor that we're talking about, responsible consumptions and production, even in the Asia Pacific regions, actually all of us are not on track for this. And not only we're not on track, we actually are making regress, trending into the wrong direction, right? So this is something that is really the global challenges, which I think the sustainability sectors, the energy sectors can really do something about it. Next slide, please. And this is why partnership with the universities organization becomes very important if you really want to solve these very complicated problems. There's no way, even if you're not a startup, even if you are well-funded international organizations, to be able to tackle all these areas of energy sectors, domains, it will be very expensive and costly. And these are the things exactly where we can really rely on open innovation model, directly working with the universities to really strengthen and really build applications that can go to the market much faster, right? So as a startup, the focus should always be how can you quickly commercialize and how can you quickly monetize your solutions. And a lot of the research, you can actually tap into these open innovation platform to help you better speed up the application development phases. Next. And one of the projects that we have done is actually with ERIAN and as well as a public listed companies from Taiwan. They're one of the largest power electronics power supply manufacturer. And as a company, as we are entering into this spaces, we realize that hardware, physical hardware, at the end of the day are the enabler pieces for a lot of these software abilities, right? Even without these enabling hardwares, a lot of the things that we want to do at the software level will not be able to translate into real savings or real output. So, but if we as a company want to directly work with a lot of these bigger conglomerates, it will be almost impossible, right? And this is where when you can leverage on really an open system innovation approach by partnering up with universities like ERIAN, NTU and ERIAN, and to work with another conglomerates who are very strong in power electronics and power supply product, and where a startup can come in to really focus on the software aspect and then also the innovation model, business model. I think this kind of collaboration can really shorten a product to market phases. So in this particular collaborations, we're developing bidirectional inverters that can help us better to do a lot of the market trading activities when the market begin to open up. So in terms of the scope of the collaborations, of course, the main IP actually comes from the universities, and where the startups actually are much stronger in developing platforms, software, and algorithms. And the big manufacturing companies are really good at cost down and then making sure that the hardware prototype can really be scaled for and be ready for design for manufacturing, right? So by the three of us joining together, we can actually make sure that the whole collaboration timeline becomes much shorter, and then it's much ready to the commercialization phases at the end of the day. So this is just an open innovation model that we actually gone through on ourselves to see how beneficial that is when you want to talk about multiple end-to-end vertical integration work. Next slide, please. And again, one of the things that we really leverage on as well to expedite these kind of sustainability innovations is really the testbed that is available, right? Because a lot of these technology without a proper testbed, it's very difficult for us to commercialize well. So that's one of the aspects we tap on really well to really figure out, how can we shorten the product to market cycle, right? Because these are all although these pieces are, people might think as infrastructure, hardware, a bit boring, but these are the enabling pieces for any of the monetization models that you want to do. So these are the fundamental things that we're really tapping into the ecosystem to help us build. Next slide, please. So with all these support from the ecosystem, again, my opinion is that startups are always known for being able to move very fast and then being able to iterate with their software approaches very rapidly, right? So this is exactly where the startups like us are focusing on. With all these enabling hardware and infrastructure, we really focus on how can we convert sustainability using the latest business models such as subscription, right? So instead of paying upfront cost to onboard different asset classes, different equipments, we're literally just charging a few $100s a month and then apply the same AI analytic and same advanced analytic to the cases, right? And then you can really achieve a dramatic market differences when it comes to pricing and etc. Right? So this is an example how everyone can really leverage on this strength and then really to monetize a lot of things. The moment we introduce a subscription model, there's a lot more data to be available, and that's when we can start monetizing a lot of these data and then come up with new business model that wasn't there before. So I'll give you an example down the road as well. Next slide. So this is some of the things that we're currently working on. Because we have hardware manufacturer, global manufacturer, because we have IPs, and because we have software platform, we are able to start to really focus on the mid to low end market for commercial buildings, industrial factories, and also power plants and utility places. These are the places usually for the high-end sector within these spaces. You have a lot of players are tackling over those. But when it comes to medium and low-end margin of those spaces, a lot of the commercial buildings, smaller buildings are being ignored just because the existing market solutions are too expensive, right? And this is exactly why we're using the subscription model to tackle them. And the moment we are onboarding about 100, 200, 300 kind of numbers of buildings in different classes, this is where you can really leverage on data analytic to figure out, where is the opportunity, how can you aggregate these data to generate new values and etc. and match these decarbonization opportunity directly to the right solution owner. Because what you see in the market right now is that it's very, very silos. You have a lot of people who have a lot of wastage, different kind of wastage, but you also have a lot of people coming out with different solutions. How exactly are these two can be matched effectively is something that is still being done mostly through a consulting, manual labor approach, right? So this is exactly where we can leverage on data to bridge these market mechanism and then to really to monetize from this whole platform approach, just like exactly what the e-commerce has gone through. Next slide. So I'll give you some example of what we mean by data monetization, right? Just with the same energy data, the raw data itself can already help you reduce your energy bills, reduce your wastage, and also improve your overall equipment productivity, right? So even without doing much processing, the first usage of these data, you already can achieve that. And these are mostly equipment level of data, because at the end of the day, it's still these equipments that consume all these energy. And the moment you look at the second layer of data, this is the second way that you can really monetize the data, is once you process these raw informations, you start looking into productivity management, you start looking into vendor management, you start looking into predictive maintenance, right? So this is the second way you can really start to monetize the same sets of data. And when you talk about monetizing the process data, you're focusing more on manpower management, vendor management, etc. Right? So this is the second way that we're monetizing the data through the platform approach. And the latest one that we're currently working on to monetize the same sets of data is what we call as a tokenized data. Right, so with all these informations, you can be able to use this data to offer, carbon avoidance, potential carbon offset, carbon credits, and all these kind of third-tier monetization strategy. Right, so one example I can give you, one of the things that we're currently working with in one of the leading hotel groups in Singapore is that because they have all these data digitized from their operation site, it becomes very easy for us to compute and then provide readily available information for the hotel guests when they check out of the hotels. We can give them the information of exactly how much is their carbon emissions. And throughout this process, not only you generate awareness, but you also give the guest an opportunity to offset it, right? So again, this is a new way to be able to get the end user to be engaged in this whole sustainability journey. And study has shown that the current trend when it comes to especially the Gen Y and Gen Z, they're much more willing to spend on all these sustainability CSR related activities, right? So these are the new things that we're currently monetizing it with the group, and all these data that we use are still the same raw data that they already have, that are already being used to do their daily operations. So this is really just an example of how the same sets of data can be monetized in different ways, and also to be able to still move forward the sustainability agenda. Next slide, please. So with that in mind, again, in order to do all these, I think the ecosystem support is very important. So how we manage to get really, first of all, break into a deep barriers of high barriers of entry industry like energy is really to tap into the available ecosystem, like the open innovation platform that the universities are leading. Subsequently, as a startup, you really need to have a case studies for the industrial players to really work with you, right? Because no one wants to be they call it as a lab rat. So this is where governments are now really opening up opportunities for startup to collaborate. So by working on a lot of these government projects, this is where startup can really build their early track records. And once you have these early track records, it becomes much easier for us to work with the leading industry conglomerates or leading industry players. And this is how we can really build up this whole growth when it comes to startup growth, and also when it comes to be able to collect data and monetize it in a larger platform. Next slide. And just the final example of some of the things that we're currently working on because of all these. We actually, because of all these work that we've done, especially able to offering an end-to-end approach towards decarbonizations with a lot of the different various of IPs and support from the governments and from the universities. We actually got the new Taipei City, Taiwan mayor, came over to our office last year. Right? And then his problem is very clear. They have 20,000 factories in one city, in his city. And he wants to see, with subscription model, with all these data monetization strategy, how can we help transform these 20,000 factories into more towards green manufacturing, and then start to spin off all these new green sustainability services. And these kind of opportunity previously will not be available to startup, and typically only the big players can potentially go pitch to a B2G project. But with the ecosystem approach and with data, this is something that we started to see very much happening. A lot of the governments are directly engaging startups to really work on these large-scale, high-impact projects. Next slide. So with that, this is my conclusion. At the end of the day, what we really focus on is really how can we use AI and data to simplify sustainability and to simplify energy management. Right? When we work with the United Nations Development Program, the number one issues that a lot of them struggle with is that when they successfully fundraise for emerging countries, and then when they successfully acquire the technologies that need to transform these countries, and then once they deploy, after a few years, the moment they remove the support, a lot of this infrastructure will just falls apart on its own, right? So how can we use AI to make sure that all these technology and infrastructure can continue to function as we move forward? So with that, thank you. That's my presentation.
Thank you, Ted. Time, okay, for questions. I'm having some questions. Okay, the first is to John. John, I have two questions for you, and they are recurrent. Okay. First of all is when have you implemented your technology? And the second one is about, okay, a comparison, a cost comparison between your power production and other, okay, technologies. Can you answer, John?
Yes, I can. Good questions. Basically, we went around to a lot of our initial potential clients, and we asked them what do we need to demonstrate in a near field scale demo, and they came up with a bunch of particular things. So we ended up doing a field scale demo that wasn't full commercial size, but answered all those technical questions, and that's up in Canada and Alberta. And that's been running since last year, and really, we ticked all the boxes on what we had to prove, the way we intersected the wells, the way we sealed the wells, validated our thermodynamic model and everything else. So that's there. And that was the proof that a bunch of other counterparties or clients needed to start signing up for commercial implementations. Our first commercial implementation is going to be in Gerets Ried in Bavaria. I've been working on that for a while. It's a site that was a failed traditional geothermal plant or prospect that they drilled down and found hot but dry rock, not the rare reservoir that they're hoping for. But of course, that's no impediment to us. We can go pretty well anywhere, permeability or not. So we're in the process of doing that and raising funding on it, and been working on feed studies and everything for that. And that should be starting next year. But we've got a bunch of other commercial prospects that we are pursuing, from Nevada to St. Vincent and the Grenadines, from Japan to where have you. We're doing as many as possible in parallel because these type of projects take a while to go. As to what the cost of it is, or levelized cost of electricity, as people would say, we've got two different products. On the heat side, of course, we're pretty competitive with natural gas right from the start. Electricity is harder because you're going through, usually have about a 13% efficiency ratio. But on those, we're starting obviously where the low-hanging fruit is, because at first, commercial implementations are going to be somewhat expensive until we go down the learning curve. So we're talking about 15 cents or more per kilowatt hour. But when you're doing that for a remote location where you're competing against diesel, or you're in Germany or Japan, or you have 25 or 30 cents a kilowatt hour as a feed-in tariff, we can make good money there. But ultimately, our goal and our plan is to drive down the cost to about 5 cents a kilowatt hour, which is extremely competitive given that we're not solar, that's intermittent, but we're dispatchable, scalable green power. Hope that answers the question.
Thank you, John. Mr. Parik, I have also two questions for you. One is about the future of SMES, and the other one, you can combine them into one answer if you want. And the other one is, how does JP plan to gain from the test bedding of SMES?
Yeah, I think like what I mentioned during the presentation as well, definitely for a scale that we have, the most important is to actually identify and track all the energy that is being consumed in a large facility, and then try to balance it. So that's where exactly SMES comes into the picture, wherein for definite, especially for new developments, when you have the optimization tool to actually right size all the equipment for energy generation at the source, at the site itself, and at the same time you balance the load. And I think SMES is going to give us a very, very good insight in terms of the data, wherein I think even Evercom mentioned about it in terms of how it is going to drive business decisions in future. And then at the same time, make use of all this to drive down the CO2 emissions. I think in terms of the future of SMES, I would say as we do this and we try to kind of legitimize the data in terms of and translating it into the CO2 footprint, it is going to help organizations track their CO2 footprint in a much more efficient manner. So I think that's where in future SMES can help us in tracking all of our footprint. Yeah. So I hope addresses that, the first question.
Yes, I believe so. Okay, Mr. Tariq, I have another question, okay, about the data integrity. Okay, how can you ensure, I don't know if you can answer or it's, how can you ensure data integrity between your customers, collaborators, institutes, and yourself?
Okay, I think that's a very good and a very important question.
You are really a hub of data.
Yes, I understand. And I think it's a very, very important question. And I believe Sheriff and team would have received the same thing from us when we started off, because our data was at stake over here. And this is exactly what we asked NTU and even the ERIAN team. And we kind of went through that rigorous process of understanding how this data is being done through the Spark gateway, I mean the Singapore Power gateway, is being then transferred as well as stored. And I think in this case, especially, the purpose of this data is pretty important. So how we use this data and where it is being kind of applied, it will then set the context of the data security over here. And especially in terms of the customer's data, I would like to say that in case of Jurong Port, we are using SMES to only track our energy. And for those which are our customers, we are not directly doing that. But I think in future, we would like to do that and obviously give them an assurance that that this data is actually secure. And we want to first test bed this thing and then implement it in future. The whole idea behind this is that the insights that will be achieved from this data is then going to make, or rather help the businesses to make certain decisions in terms of their energy and their energy utilization. And that's where I think the ecosystem will then understand the benefit of doing this. As for the integrity, I believe there's a lot of stuff that is going on in terms of data security, and all our Jurong ports, as well as even the technology providers are definitely trying to safeguard this info.
Thank you, Mr. Tariq. I believe I have a last question for Ted. Ted, the question is about, okay, if you have any advice on how to better work with big corporation, institutes of research, okay, for tech commercialization, and somehow also how ERIAN could help you or help a startup. Can you answer, and combine in one answer, these two questions? So I repeat, one is more about an advice on how to work with big corporates and institutes, and the other one is how you can get benefit of these institutes.
Yeah, I think we went through a very steep learning curve. So we started to work with the bigger conglomerates in the regions and also with the research institutions. I think one of the things that going into this kind of collaboration is very important to attack the project with a very strong commercial angle and business model in mind. If you have a strong business model along the way in the development process, there's always times that whichever questions that arrives, there's always 1,000 ways to do things or resolve things technically, right? But from a business endpoint, if you always have a strong business application angle, and you know exactly what are the price range and all these that you want to address, then a lot of it will automatically filter out a lot of these technical considerations. So because the worst thing that in the early days that we get ourselves involved is to debate about 8 different technical ways of getting something done, right? Without a business as a guidance, you can go on with those debates for forever. And the worst case is that you choose a particular way and until the end you realize commercially it's not really a viable way. So I think to be able to, in order to work with all these different organizations, the business model and also the target markets and even how you want to monetize it potentially, as long as you have a very strong framework of that in mind, it's much easier to streamline the discussion with different parties. And how these organizations, like if it's a wish list from us, I think it's more about how can we make a lot of these technology a lot more simple to understand, right? It's always easy to make things more complicated, but especially in the energy spaces, the domain-wise is always these big categories. So it's very hard a lot of the times for us to understand what is the nuance differences between something. So that is definitely something that we want to continue to be able to work with the research institution and be able to better learn what are the differences. Thank you.
Thank you, Ted. I believe it's time to switch to the other topic. So just a small reminder, we are speaking, the second topic will be about, DERs, which stand for distributed energy resources, which are, the solar panels, the batteries, the charging stations, the electric vehicles. We all know that, Mr. Siakeng Boon will be introducing, the concept of VPP, virtual power plant. That means when you have different energy resources, you can combine them into one virtual power plant. This will be about his presentation. But then, Mrs. Anne and Jean-Philippe Coury will more speak about, what are the impact of the introduction of all these resources. So we know now that when you increase the number of DRs, to a network, you are bringing stability. And so how you tackle, this instability issue, and then how you are able, to use at the best, this energy and have more flexibility. So I give now, I ask now, Mr. Xia, to make his presentation. Mr. Xia is the head of advanced engineering and technology in SEMCOR. In fact, he's the head of the R&D. He's our day-to-day partner, for our projects in terms of energy. Mr. Xia, will cover a new topic, what I introduced before, which is the VPP. So please, Mr. Xia.
Thanks for the kind introduction, Sheriff. First of all, I would like to thank the organizer for the opportunity to share our journey of this innovation and develop an interesting solution called virtual power plant to get ourselves ready for Smart 2.0 Singapore. So next slide, please. I'm from Sembcorp. Sembcorp Industries is a leading energy and urban development group operating across multiple markets worldwide. As an integrated energy player, Sembcorp is positioned to support the global energy transition. So we leverage on technology and digital innovation. Sembcorp provides solutions across the energy and utilities value chain. Sembcorp has a balanced thermal and renewable energy, including battery storage for over 12.6 gigawatt over the world. And besides energy, we also have a strong urban arm, which is recognized to be a leading ASEAN developer with a strong track record in transforming raw land into sustainable urban developments. We have 11 industrial parks in Vietnam and and also some in Indonesia and China too. So we also listed in Singapore Exchange and also a component stock of sustainability indexes such as Dow Jones Sustainability Index. Next slide. Okay, so next slide, please. So for this presentation, I will talk about the virtual power plant. Next slide, please. One more slide. Yep, thank you. So for majority of the industry, we are facing various major trends that are affecting and disrupt our industry. Similarly, Sembcorp in energy sector, we are facing the same huge disruption along the way. Urbanization, for one, has increased energy consumption due to the three pathways: urban spatial expansion, urban motorization, and also the rising quality of energy-intensive lifestyle. What has happened is for such urbanization, the electrification in commercial and residential building has huge impact to the grid system. The timing of the peak electricity demand, the shifting of the power system from day to night, and during this transition, the huge increased rate or decreasing rate of the demand have put a huge burden to our grid system. Electrification in the motorization is not new. In Singapore, since 1980s, we has already going through this electrification from a public transport point of view. So with the MRT railway system getting more and more common, electrification in the transportation is happening. And the second wave is coming as well with the introducing of electric cars into the system. And this has also give a lot of issue potentially in terms of the intermittency in the demand. Last but not least, the green drive is gaining a lot of popularity. The decarbonization of the electrons is happening, especially when the cost is going down. The proliferation of the renewable energy, especially in Singapore, which is solar-based, will have huge impact to the intermittency in the grid. The cloud formation in Singapore is very, very challenging, one of the most challenging ones in the world as well. This has caused increase in the sudden increase and the drop, during even the daytime, not to mention about day and night time. And thus, how are we going to overcome this? Because traditional grid, which is very linear, one-way power flow from generation to the users, to the demand side, will not be able to handle this sooner or later. This type of unidirectional power flow with little control of power quality besides using high percentage of reserve capacity actually are costly. Next slide, please. With that in mind, there comes the initiative to make our grid smart by having this smart grid 2.0. With more distributed energy generation, the grid has to evolve, have to transform to handle multiple producer, multiple consumer in the electricity grid. So under this Smart 2.0, there are a few outcomes that we would like to see. One, the improve of reliability means that ensure consistent performance with minimum outages. The improve of resilience, meaning when there is an outage, how are we going to quickly recover from this self-healing process? And also the other outcome is always at the customer side, as the consumer side. How are we going to provide this awareness with sufficient data to the consumer to allow them to decide the change in their lifestyle to help in this grid transformation? Fourth, in efficient energy usage as well. So there are a few initiatives that we can talk through. Optimization of the energy stream as one. Two, building infrastructure to modify, to accept like what Tech has mentioned. How do we make it through the technology to increase the power to accept DC power directly from various sources? And third is energy consumption patterns. The other two very important outcome that we would like to see from this Smart 2.0 is also allow the increase of the penetration of renewable energy. Currently, with the front-loading effort that announced by Minister Chan on Monday, we will be expecting by 2025 there will be a larger share of renewable resources, especially during the daytime, into double digit and may hit as high as 20%. How are we going to handle this under the Smart Grid 2.0, and also to allow more market participation where there will be energy generation capacity which is currently idling, and how to help to increase to optimize the capacity that currently is not really running at the optimal. Last but not least, is always grid system always occupy a real huge area as well. If we can find the synergy between all this distributed energy distributed around Singapore, rather than having one big power plant situated at one corner of Singapore, basically we also be able to increase the potential land area for other purpose as well. So this is not possible without using new technology, new innovation. There will be new requirement, more requirement on the new IoT system, power electronic system, and more importantly, digital technology. So to help to realize the success of the Smart Grid 2.0, EMA, Sembcorp, ERIAN has come together last year to develop virtual power plant. Next slide, please. In a nutshell, the virtual power plant that we envisage is actually the key points that what Sharif just now has briefly introduced is the aggregation. What are we trying to aggregation? Aggregate is the idling asset that is more not able to participate in the market efficiently or cost effectively. If we are able to build a digital platform to accumulate or aggregate all these small idling assets and participate in the market, that will save a lot of potential investment, land area, and as well as improve on the quality of the electrons that the consumer will be able to enjoy. I have a video to describe fully the virtual power plant that we are doing currently together with the partner. So the video.
A virtual power plant aggregates and manages distributed energy resources, known as DERs, such as solar PV generators, energy storage, and gas generators, as well as building loads. Up to thousands of these assets can be scattered across residential, commercial, and industrial locations. This portfolio of energy assets, combined into a single entity, operates like a conventional power plant. It brings about new opportunities to the DERs by allowing them to participate in the energy market, including grid ancillary services, such as frequency regulation and reserve, to enhance grid stability. A virtual power plant brings value to the regulator, asset owners, traditional utility companies, and the consumer. A VPP facilitates a more diversified and dynamic energy market by facilitating cleaner energy sources into our energy system. For the asset owners, a VPP captures more value from DERs by enabling market participation, thus bringing higher returns and encouraging investment into renewables. The VPP enhances grid stability with services to better match supply and demand, allowing traditional utilities to better plan and optimize production efficiency. A VPP increases DER's returns, thus encouraging more renewables installation, leading to a cleaner and more sustainable energy supply, ultimately benefiting the consumer. Energy Market Authority of Singapore and Sembcorp Industries Limited, in collaboration with Energy Research Institute at Nanyang Technological University, have embarked to build Singapore's first virtual power plant. This project aims to contribute towards Singapore's efforts to meet its climate change commitments by allowing for more clean and distributed energy resources, such as solar, to be integrated into Singapore's energy mix. Our research leverages recent developments in information technology, such as large data transfer in real time, advanced forecast with smart algorithms, as well as innovative strategies for optimum dispatch. Using data science and machine learning algorithms, we target to produce more accurate predictions for solar power generation, building load demand, and electricity price forecast. In our VPP, we are developing localized forecast methods using sky cameras and various weather sensors to achieve higher accuracy results. Depending on the look-ahead time horizon, these parameters can improve on existing forecasting algorithms to give a better prediction on the solar irradiance profile. Our optimization algorithm takes in the various forecast profiles and computes the optimum power dispatch for each of the energy assets for a future time horizon. This enables the energy assets to operate optimally for maximum return. Let's take a look at the projected dispatch profile of the energy storage system. We can observe that energy is purchased to charge the energy storage at low prices and sold at high prices in the energy market. Furthermore, access to the grid ancillary services market offers opportunities to generate additional returns. Our algorithm considers the potential value streams of different grid services to optimize the energy storage utilization. Our user-friendly trading advisory dashboard offers comprehensive information in the form of tables, charts, and heat maps. Here are the charts showing the grid services to be offered by the VPP for the next 24 hours. For the frequency regulation service, the optimization algorithm proposes different bid quantities based on the price profiles and the state of charge of the energy storage. On completion, the virtual power plant will include 4 locations spread across Singapore: 2 residential sites, 1 recreational facility, and 1 industrial site, with assets including rooftop solar, floating solar, as well as large-scale energy storage systems. This project will serve as a blueprint to bring this technology to future large-scale commercialization. We hope the knowledge gathered and shared through our research and implementation will help to diversify and improve Singapore's energy market. Join us to create a more mature and resilient energy market.
Thank you. So apologize for being lazy to present on the spot by using the video, but I thought using the video will capture the full story. Having said that, next slide. Besides some of the application that we mentioned just now, there are also many other applications that we can build on top of the virtual power plant, especially when come beside the ancillary services, but also some other so-called merchant applications that we foresee to be more and more gaining more and more traction. May not be in Singapore yet, but already seen it overseas. So of course, in this 2 years program that we have with ERIAN, we are not going to build everything. That's where we are also urging potential collaborator to jump into this wagon to work together with us to realize the smart 2.0, grid 2.0 of Singapore to as early as possible too. Next slide. However, this journey is not without any challenges. So there are plenty of challenges when it comes to technical, market, or regulatory. So some examples are currently in terms of the metering scheme, there's no suitable metering scheme when it comes to a few generator at one site, right? So current system is such that there's only one generator, means 1 meter, maximum 2, right? Yep. So how are we going to overcome this? There's a need to change the technical receiving part at the other end of the grid system. Communications currently, for example, everything in order to make it secure for frequency regulation specifically, we need to use pilot cable, which is a physical wires. Can we do something else? Are we able to use the future 5G or 5GA where we are able to allocate certain bandwidth specifically, depends on the signal flows, right? To ensure that we have a very dedicated and reliable bandwidth for communication between the asset to the PSO service server, for example. Why do we need to have that? Because it will be very costly to build all these cables, hard wires along all the very smaller distributed asset, while the cost to build this kind of cables will be too high to bear and deter the VPP to aggregate all these distributed energy resources into one single platform. Besides that, there are also certain market so-called consideration that we need to ensure that this will happen. For example, the different type of asset when come to participating different market, the value is not well defined. So example, energy storage, lithium, for example, battery. They can provide, this type of system can provide much faster regulation services than conventional generator. However, the compensation mechanism has not been appropriately valued with respect to the performance characteristic of energy storage. Of course, the movement so far after 1 year into this project, a lot of progress has happened. We have a lot of support from Singapore Power, EMC, the agency, from policy, from PSO, have allowed us to move ahead and I wouldn't say remove, but smoothen the process to ensure that our VPP during this test bidding process in able to move on to the next stage. Next slide. So we are not going to be working alone. We can't work alone as SEMCOP or as EMA or as ERIAN. We need more collaborator to jump upon this wagon. So just now we have Sharif and Peric has talked about smart multi-energy system earlier. We are actually in discussion to allow to explore how can we make use of this multi-energy system in the various sites and allow VPP to talk to this energy system platform to platform to ensure that after they optimize their asset, how are they going to participate in the market via VPP. Besides that, they are also at buildings level where like what Tech has mentioned, he has optimized the consumption, the energy efficiency at the building level, be it factory, commercial system, or big, large-scale residential area. Using their optimizer, after they have optimized it, are they able to talk to our platform? Because when after their optimization, they may also left with very little idling asset left. But this idling asset, if we are able to tap into the VPP and aggregate them together and participate in the market, basically it can further enhance in terms of the cost saving and allow the user to enjoy lower cost, greener energy as a whole. So with that, I would like to urge potential collaborator in this platform in the audience to contact us to explore potential collaboration in the near future. With that, thank you.
Sharif, I think you're on mute.
I was on mute. So first of all, I want to thank Mr. Sia, and the discussion will continue. I want to welcome Jean-Philippe. Jean-Philippe Lecouri is driving the business of smart grids in Schnell for all Southeast Asia. And he's coming with a presentation about the paradigm change. You know, electricity is living a revolution. For 200 years, we are only speaking of UI and cost fee. And today you have artificial intelligence, you have business around the grid. And it's a complete revolution. So I let now Jean-Philippe introduce us more to this new paradigm.
All right, thank you, Sharif, for the introduction. Good morning, good afternoon to everyone. I will talk briefly, 10 minutes, on the major trend that we see in the utility industry. And in advance, I would like to apologize if my voice freezes sometimes, because it seems like I have a bit of connection problem this morning. So if you see that I'm not moving anymore, it's normal. It's not part of the presentation. So if you can move to the next slide, please. So what we all know is that the world of energy is changing, and the power industry is facing very big changes. Among the different trends that we see, we first expect to see an increase of about 60% of the electrical demand within the next 30 years. And this is creating a real issue because electricity generation accounts for more than 25% of the gas emission worldwide. So since we cannot really stop the trend of having a world which is more electric, there is a need to decarbonize the electricity generation. We have therefore trends that we call 3D. So 3D stands for decarbonization, decentralization, and digitization. So those trends are shared by most worldwide stakeholders, and it's not just Schneider Electric speaking about it. So as I said, the first D stands for decarbonization. So 86% of the power generation investment will be zero carbon fuel until 2040. And those zero carbon fuel are going to affect the way utilities are managing the network, mostly because of the intermittency of those sources of generation. So if you take solar, for example, if there is sun, there is power, there is no sun, there is no power. Secondly is about decentralization. So not only the power generation will be made of renewable energy, a large scale, but instead of having only those large-scale power plants connected to the HV substation or MV substation, you will have a lot of scattered power generation all over or all across the network. So everybody, for instance, starts putting solar panels on their rooftops. So this has an impact for the utility, as they have to maintain the grid balance and they have to avoid any capex investment, like for the reinforcement of the grid. So we need new ways to anticipate what will be the production of electricity and how to have a grid which is more flexible. And speaking about flexibility, this is leading us to the third point, or the third D, which is about digitization. So you cannot have flexibility without measurement, and you cannot have flexibility without communication. There is a big rise of smart metering, for instance, and utilities which used to manage the dispatch of electricity and electricity only are now managing trillions of data. And this has an impact on cybersecurity, since if you want to put down a country, you will start targeting all the critical infra, and of course, the network, the electric network is one of them. If you can move to the next slide, please. So Schneider Electric is a very big company, and it's a company present in every part of the world. In terms of utility, we are mostly focused on distribution utilities. So we did interview all our distribution utility customers worldwide to understand better what were their challenges and what they see, what are the challenges that they see moving forward. So what you can see here on that slide is that each region has its specific needs. So there are different trends, different regulations moving forward, different pain points, different quality of supply, but we can still summarize all those pain points into 6 domains. Next slide, please. So there are 6 major trends which prevail. The number one, if we go one by one, it's about changing the regulation and the policy. The distribution utilities worldwide are strongly regulated, whatever the market model. And the utility regulation was invented late 19th century, and it was not really meant for decentralized power system with renewable. So regulatory evolution is on the horizon, and it generates uncertainties, which impact it will have on the investment strategy, on the revenue model, on the associated risk management. The second is about more active customers. So here we speak about prosumers and community, which are affecting the strategy and operation of the distribution utilities. The prosumer self-consumption results in reduced energy flow on the distribution network, and therefore it impacts the utility revenue model. The number 3 is about digital transformation. So here technology is center stage in that discussion, but what is the actual level of readiness of utilities to go digital? How do they identify the possibility in that new space? How do they view the potential of new digital technologies? Number 4 is about improving the operational efficiency. So here we have main KPI, key performance indicators of distribution utilities, which are the SIEW and SIEW, the duration of outage and the frequency of outage, which are the most significant indicator for customers who are very sensitive to power outages. But we also find loss minimization, it can be technical or non-technical, customer satisfaction, which can also be incentivized, by the way. And then number 5, we have the access to energy. So that one applies only to selected region. And still in the world, we can say that 1 billion people are yet to be electrified. So this is mainly in Africa. The electrification solution can start as low as a basic solar home system up to a village off-grid power system that we call microgrid. And in some countries, utilities are in charge of managing this basic access service. And the last point, which is by far the most complex topic in the transition to the decentralized model, is the DER integration. So the basic mission of planning and operation of distribution utilities will require major adaptation to this new situation. And this is what we are going to see in the next slide. And we'll start first by understanding what DER actually means and how we define the DER penetration rates. If you can move to the next slide, please. And the next slide again, please. Okay, so there is no consensus on the definition of the DER. There are a couple of quotes here saying that we are not talking about the same story. The acronym is very misleading. And whether you're an American or European, or whether you come from one part of the industry or the other, you might have a different understanding of the acronym. Next page, please. So people have a different perception depending on the local acceptance of the term DER. DER may be understood in a more restricted way as a DG only or DG plus storage. And in some places, like in the US, the concept expands up to microgrid and even energy efficiency program. But let's say that the most future-proof definition shall be probably the third one. And this is what we're going to show in the next slide. If you can move to the next page, please. So based on the previous definition, we can identify various definitions. Where in places like Germany and California, Australia is also here, by the way, they have already entered the new era of high DER penetration. So if you take Germany, for instance, most of the wind and PV capacity is connected to the distribution, which we can see here. UK has also an aggressive policy for DER. They position themselves just after the top 3. And we qualify them as medium penetration. And I would say most of the countries do not feel the heat to the same extent yet, still with a rather low penetration rate like France. They have more time to prepare to the new model. Next page, please. So DER integration is in fact a two-fold story. It's a network integration part. It's based on control room technology that we'll discuss later. It's about new planning strategy and tools, as well as increase of DER hosting capacity, avoiding overspending on the network and avoiding the congestion of the network. And there is a second part of the story, which is a wholesale market integration, trying to bring demand response and small-scale renewables flexibility into the market, which requires aggregation and VPP, as we have seen before. Next slide, please. So as we have seen, some countries are already feeling the pain of that DER integration. So there are indeed a lot of operation constraints with DER for distribution utilities. DER can exceed the network limits and cause risks to the system security. We speak about higher MV fault level, reverse power flow, under and over voltage, overcurrent, among others. And in order to solve those operational constraints, you need much more visibility on the network, more sensors, more automation, and more software. If you can go to the next page, please. Next page. Thank you. So the software that can help manage those operational constraints, we call it DERMS. It stands for Distributed Energy Resource Management System. So the DERMS will basically model the DER, monitor and forecast, as well as optimize them in order to maintain the stability on the network. And this is, I believe, what Anne is going to present you in the next presentation. So with that, thank you very much.
Thank you very much, Jean-Philippe. Yes, I believe, okay, now it's time to go to Anne's presentation. So we had, I want to make the link, we had a presentation about VPP, about aggregation. Now Derm, okay, will speak more about the stability and the dispatch of the power. Anne Swazik, okay, is the brain, okay, I would say, of our Derm project in NTU. She's architecting with Singapore Power, okay, what should become the future grid of the nation. Anne, please go on.
Thank you, Sherif. Thank you for having me today. So this presentation will introduce Grid 2.0 energy management system from the perspective of the distribution grid as an enabler of the energy transition. So next slide, please. So looking at global trend, we see, and it has been already presented, that for sure the future will be green, with potentially looking at long-term outlook, half of the electricity mix coming from renewable, wind and solar by 2050. The second important trend there is electrification as a way to decarbonization, and specifically in the transport industry, with EV uptake having a potentially important impact on the shape of the consumption. And Singapore has strong commitment as well in regard those two trends, with a target to reach 1.5 gigawatt of solar by 2025 and a vision for phasing out internal combustion engine by 2040. In this context, quite often we refer to the grid as a legacy system. But in fact, what we will see is that the grid is transforming in the background in order to keep ahead of this energy transition and to be an enabler. Next slide, please. So why is it so important for the grid to transform? Is that because the grid is in the front line of this transformation. With the increased distributed energy resources penetration, the grid is facing challenges like undesired voltage profile, power quality issue, reverse power flow, and other that have been presented already in the previous presentation. So in this context, the distributed energy resources represent the challenge. But when we look at the distributed energy resources as potential flexible asset, in that case, the view change, and we can see those resources as providing the solution or part of the solution to managing those challenges. So what do I mean by flexibility? So eventually flexibility is the capability of an asset to adjust to external signal or changing in the environment. And we want to have there a large definition of the flexibility, having on an equal footing the flexibility from the demand side and the supply side. And what is important to consider as well is that the flexibility can be sometimes directly connected to the grid at the medium voltage or low voltage network, but as well will be located on the consumer side, what we often call behind the meter. So next slide, please. So in there, I have highlighted three important problem statements of the grid where the flexibility can contribute. The first one being the capacity. So with a flexibility into the picture for managing the grid, it can improve the grid asset utilization, accelerate new connection, and as well increase the hosting capacity for more renewable and EV charging station. The second element is the reliability that is critical for the grid. And those flexible assets, they are eventually located exactly where the new constraints will happen. So they are best place to manage and help support mitigate those constraints. So the flexibility can support and enhance the capability to manage the constraints. As well, flexibility can provide power quality support for the grid and enhance the restoration. And finally, sustainability. Why sustainability? Because by recognizing the value of the flexibility, we bring a new value opportunity for those distributed energy resources and hence support the adoption of green technology. Next slide, please. So what is there? In fact, having a flexible grid is an important change compared to how the system was working in the past. So it means having a new transactive, technical, and operational framework. And in order to have this flexibility emerge and be available for the grid to be dispatched, we have identified 4 important steps to make it happen, basically. The first step is having a system flexible by design. It means that at the planning stage, we need to be capable to introduce new flexibility options as alternative to grid reinforcement, what is often called those non-wired alternatives. To do that, we need to design or to evolve the existing planning tool and as well have the regulation evolve. The second step is engaging as I mentioned before, many of those flexibility will be on the consumer side. So it means we need to have a new transactive framework that is capable and allows to engage the consumer flexibility. The third one is technical component, most technical component of it is the connection. What is very important is the new ecosystem is that the system has visibility on what is happening down to the low voltage network. So connection means on one side, the monitoring of the network health and the distributed energy resources behavior, and as well the capability to send dispatch to control automatically the flexibility. And the last one, the fourth element, is the dispatch, is the decision-taking engine, is the brain of the system, basically, with forecast and optimization that should be adapted because it will need to tackle a huge number of potential assets that can be dispatched and used to realize the objective, which is managing the constraints as well as realizing the savings. Moving to the next slide. So as we see the complexity grow, there is a need for a digital platform to enable this flexible grid and the management of those flexibility. And this digital platform is the DERMS. So DERMS standing for Distributed Energy Resources Management System. So the DERMS, like the DR, the DERMS effectively is not a standardized platform. There is no commonly accepted definition of the DERMS across the industry. The term can be used by different offerers for platform, eventually providing diverse services or functions. So I will be more specific on which DERMS I am considering in this context. First, the scope. So the DERMS we are considering is a utility system platform and more specifically distribution grid operator platform. Second, the objective. The objective is sustainable, efficient, and reliable grid operation. So this digital platform is built as a multi-layer system that manage the asset and the network across different time frame. It is built on obviously the flexibility, the device themselves, which have some control and regulation capability. A second layer, which is optimal constraint management, so the system supervision and dispatch capability. And finally, a third layer, which is doing the planning and the orchestration. So looking ahead of time, what flexibility are required and how I should schedule the flexibility to make sure I can manage the constraints I am seeing forward. Next slide, please. So that said, what we see in the DERMS is forecast, optimization, dispatch. So you may wonder what's the difference between a DERMS and a VPP. So in this slide, I am highlighting, starting from the VPP. So that was already presented, and as a summary, the VPP, what is doing a VPP? Aggregated different assets in order to maximize the value of those assets, managing them as a portfolio and monetizing those assets across different market opportunity, as well as potential price signal. So the VPP is aggregating and stacking the revenue to increase the value of those assets. And among those market opportunity or revenue opportunity, we have providing services for the distribution grid. And this is where the DERMS platform comes into the picture. The DERMS platform will model and take into account all the grid assets, the topology, the constraints, the location, specific location of all those different consumption, DER, and flexibility, and run some optimization and some analysis of this network to identify the constraints and decide which asset should be dispatched or which group of assets should be dispatched in order to manage the constraints. And this is where the DERMS will send some dispatch command or requirement for assets to the VPP platform. So effectively, what we see is that both VPP and DERMS are partners with this objective to have a sustainable and a flexible grid and energy system. Next slide. So as we have different parties involved in this new ecosystem, in this realization of a flexible grid, there is a need for a flexibility engagement framework, what is as well called a transactive energy system. So looking from the global system balance, so what is often referred to as the transmission system level or bulk power level, there is there a need of being capable to manage the supply-demand balance. And in many countries, there are already some market framework existing from the past, with three markets I have highlighted there as the most common main market we see. So the reserve market, which is managing the regulation, primary reserve and contingency reserve, also called ancillary services. The wholesale market is where most of the energy transaction occurs in order to ensure that we have enough generation or electricity generated to meet the demand. And finally, capacity market, which is looking at the long-term adequacy for the peak demand. In Singapore, this capacity market will come as the forward capacity market under design. So at the global system level, when it comes to bringing flexibility into the picture, we have an existing framework on which we can build. It's not always that straightforward. And as pointed out in the first presentation, it might need some changes in the rules, in the regulation, but we can build on something. On the other hand, at the distribution level, so at the bottom of the slide, where the objective is power quality, reliability, and local constraints management, most of the time, there are no existing framework to contract services from external parties to the grid. So there is a need to create a new framework, a new ecosystem, new rules to allow to tap into the flexibility coming from different parties of the market. So there potentially we have different approach that we see in the country that have started this journey. One being going for flexible connection contract, more of a bilateral term. A second one being flexibility tender, so that we see in UK, for instance, where they launch a flexibility tender for specific location for next week, next month, or next year. And the third one being potentially implementing real-time markets with real-time signal to call for flexibility. So this is a journey that needs to start. In some countries, it has already started, and with different design options, with pros and cons for those different design that can be specific as well to the local context. Next slide. So as a wrap-up of this transformation, a few important ideas. First is that for sure there are major changes ahead of the distribution grid operation with the DR, the EV, and the electrification at large. And what we believe is that flexibility is a central element of this future distribution grid development, operation, and management. With two critical components, the emergence of flexible asset and flexible usage, and the development of a digital platform, the DERMS, to be capable to integrate reliable and effective grid management strategy with all those flexibility. And the two second point are important factor to keep in mind in the design to have a future-proof system. The first one is the interoperability with other digital platform, as it will be critical to have those different solutions work together to achieve a greater system operation. And the last one is thinking of the strategic cooperation, coordination between the global system balance and local grid management. And with this is the end of the presentation. Thank you.
Thank you, Anne. Okay, let's move to the questions. I have questions first of all for Jean-Philippe. Jean-Philippe, the first question is about COVID. You have listed different challenges that distribution utilities may face or are facing through their integration, the active customers, the digitalization. What's about the challenge created by COVID?
It's a good question, Sharif. So what we see with COVID is that it's really a stress test for distribution utilities, and all the utilities worldwide are being impacted. So what we can see that there are two impacts. The first impact during the crisis is more operational, because many countries, they have been through a lockdown. So their workforce also went through the lockdown. And this is where many utilities, they felt the importance of digitization of their operation And we could see that some utilities, they were not ready for it. So the first impact is operational. The second, we can say, is finance, like many companies, we can say, because clearly there is a decrease in the utility revenues. And speaking about that, there is a report from the International Energy Agency. They are highlighting that for a sustainable recovery post-COVID, many utilities are encouraged to continue to expand and accelerate the modernization of existing grid, including through the rollout of smart grid. So to answer your question, Sherif, yes, there is an impact, both operational and financial. And the best way to recover and be resilient on the long term is to go into the digitization and modernization of the grid.
I have another question. Thank you. I have another question. It is okay. It's coming from a customer of one of your competitors, I believe, because he says that there is many vendors, okay, in terms of DERM solution. What differentiates Schneider?
Okay, so outside of the fact that we have, of course, the best solution, Sherif, you know, DERMS is a very new concept, which is still emerging, and therefore the definition is quite vague. So we can classify DERMS into two types of solutions. One of them, we can call it a DER aggregator. So it's a very basic solution for aggregation of small resources. And we have another one that we can call utility DERMS. So the aim of the DER aggregator is limited to aggregating small, usually behind the meter DER, and to provide various services like market participation, demand response, load shedding. But those DERMS, they don't really have access to an accurate system model. They are completely unaware of the system constraint. On the other hand, you have the utility DERMS, which can do what the DER aggregator DERMS can do, but also can use all those resources to answer the system constraint because you have the accurate model of all the network. And you can even go further and use all those resources to solve already violated constraints and return the system to its stable state. So as a summary, the utility DERMS should be understood as one hierarchy level above the DER aggregator. And it sees the DER aggregator as the resources available for using it in its advanced applications.
Thank you, Jean-Philippe. I have a question from a consumer, for a future customer, for Mr. Sia. Okay, the question is about, it's a customer who says future customer. What are the expected return for Singapore customer with the VPP implementation? Is there any reduction on the energy bill?
That's definitely our aim to get all the benefit, not only the cost, but also make the electrons that eventually come to the customer green as much as possible, be it through efficiency or be it through the more proliferations of renewable energy. Unfortunately, I must say that I do not have a figure, a concrete figure in terms of the ROI or payback for the future customer, be it they are owning an idling asset, or be it they want to invest into the renewable energy like PV and so on. But we strongly believe that after our program completed or before it is completed within this 1.5 years later, we will be having a more concrete number to share with this potential customer. But meanwhile, do feel free to drop us emails because this journey will be a very interesting journey for both parties because the return in terms of the payback and ROI is very much depending to case-by-case situation. Yeah.
Thank you, Mr. Sia. Anne, I have two questions for you. The first one is there money for utilities, for grid operators? This is the first question. The second is about what the challenges in terms of grid feasibility you have in your program, in the program design.
All right. So for the first questions, I don't quite get it, but are you saying that this product is for which so-called customer or the owner?
Soros, yeah, okay, the question was for Anne.
Oh, sorry.
No problem. So, Anne, the first question, I repeat, it is about is there for grid operator?
So, as explained, so the DEMS, as the definition we use of DEMS aligned with what Jean-Philippe said, is the platform for the grid operator. But the DEMS is connecting to the VPP, is connecting to different platform, managing and aggregating resources to create value for the customer. DEMS can as well enable the flexibility itself for customers that would like to opt in directly to those new services opportunity. So the customer can opt in the future. The vision is that the customer can opt in via a VPP platform, via a third party that will support in this journey, or may opt in directly to the DEMS system. And the second question regarding the program design, I believe that the most important is to engage the different stakeholders, because it is a quite complex system, and because of this location constraints, the resources that effectively can support may be limited, because the constraints are located at specific space. So there is a need to engage the different stakeholders to make sure that the way the requirements are designed allow for a successful and high rate of participation of the flexibility provider.
Okay, thank you, Anne. It's 11 precisely. It's the end of our workshop. I'm impressed because we could really finish with the last question on time. Okay, thank you all for your participation. Thank you for people who are following us. I believe that we are over 300 people, okay, attending. So we shall continue the discussion with each one of you, okay, later. And have a beautiful day. And thank you.
Thank you.
Thank you.
Thank you.